Hey, what's up? It's your old pal, Mr. Cook. We just went through the first 10 questions. Now let's go through the next couple. I guess we'll do, I don't know, 11 through 14 on this video. So use the information provided to write the standard form equation of the circle. Okay, so this is a circle. A standard form equation for the circle looks like this. It's got x minus h squared plus y minus k squared equals r squared. That's the standard form equation. And h and k are, from the center of the circle, like whatever coordinate that we get, that's the center. And then r is, you probably guess what it is. It's the radius. And I just literally plug those numbers in. Here are the three things that I got to plug in for every circle equation: the center, h and k, and then also r. So it should be left in terms of x and y, right? So if you have x and y left over, that's like by design. Okay, so the center is the h and the k value, and then the radius is r. So if I just plug those into the equation, here's what I get. X minus h, so x minus negative 14 squared plus y minus k, which is 1 squared, is equal to the r value squared, so 3 squared. And then I just do some simple math to make this look a little nicer. Subtracting a negative, that gives me a plus, so positive 14 right there. And then 3 squared, last time I checked, that's 9. There we go. We've got this circle in standard form. We're going to do the same thing with number 12. We're given the h and the k value and the r. And we just plug it into the formula again. X minus h, so minus a negative 12 squared, plus y minus k, so minus 5 squared, is equal to r, which is square root of 47 squared. Then we just do our simple math to make it look nice. Subtracting a negative is the same as adding. 47 squared, square root of 47 squared is just 47. The square and the square root cancel out. There it is in standard form. So there's 11 and 12. The next thing we have is a parabola. So parabolas are a little weird. Oh man, I got to remember the formula for this one. I think it's let's see here, x minus h squared, and then times, is that the part that's times 4p, or is it 1/4? I think it's then 4p times y minus k. Oops, y minus k. Yeah, I'm pretty sure that's what it is. And that's for a parabola that's got an x squared on it. And that's when it'd be going like up or down like that. And then the other formula looks like this: y minus k. Gosh, sorry, my screen keeps moving. Y minus k squared is equal to 4p times x minus h. And that's all from memory. That's the one that either has a parabola going to the left or the right. I'm going to use my phone real quick to make sure I got those formulas right. Let's see, parabola, standard form. Yeah, 4p y minus k. Yeah, wow. Can't believe I memorized that one. Okay, so yeah, let's take a look at these parabolas. Now, p, this letter p right over here, I better describe that to you real quick in case you didn't know what that is. Because that's the only thing that is a little tough, because the h and the k values in both of these cases, h and k, come from the vertex. So if I know what the vertex is, I know what h and k represent. And if I have another coordinate, then I can find p pretty easily. But if I don't have another coordinate, if I'm given something like the focus or the directrix, I better know what those represent. So here's what they are, right? So let's say that we've got a parabola that's opening upwards like that, okay? The vertex is right here. And if you go up or down by some amount p, that'll give you the location of the focus. And if you go down by the amount p, it'll give you the equation of something called the directrix. The directrix is either a horizontal line that's behind or above a parabola, depending on what kind of parabola you have, if it's facing upwards or if it's facing downwards. And if it's a parabola that's facing to the left or to the right, the focus is either to the right of the, it's inside the parabola, and the directrix is on the outside of it. And again, it's this length p away from the vertex, okay? So all that I'm saying is that p is kind of the distance from the vertex to the focus or the directrix. It actually kind of doesn't really matter. depending on what you have. All you got to do is just like graph it out, and you can tell which one of these two shapes it's going to be. It's either going to be a parabola that's opening up or opening down, or it's going to be a parabola opening left or right, like that. Okay. So that's like the first thing you want to do. See if the parabola opens up or down or left and right, and then pick the equation and then find the coordinate that's missing. Okay. So let me show you how to do that. So if I know what the vertex is, it's -1, 4. I'd graph that point out, just really crudely, -1 and then +4. So it's like the vertex is up there. And then I would graph the focus, that same exact, that coordinate. Just graph it the same exact way. Just graph the coordinate. So it's over to the left 1, and then it's up 63/16. Gosh, let me get my calculator real quick to see what that translates to. I think it's like just under 2, right? Is that right? So let me check. 63/16. Oh, it's just under 4. Darn it. Yeah, I was off by a little bit because I was thinking 64, but whatever. So it's just under 4. So like the focus is going to be below it, right? So it's like -1 and then just under 4. So like right there, there's the focus. So what that tells me is this. If I graph it out, right, the focus is inside of the parabola. Okay, so if I've got like a vertex here and a focus here, that means that my parabola is going to open downwards like that. Okay, if I had it the other way around, if my vertex was here and my focus was up here, right, that means that since the focus is inside the vertex, my parabola would open upwards like that. Okay, and same thing with left and right. If I had my vertex here and then my focus was like to the right of it, okay, like right over here, then that means my parabola would open up like that because the focus is always inside the parabola. So this tells me that my parabola is going to look like this, because if this is the vertex and that's the focus, then it's going to open downwards. And if the parabola opens downwards, it's one of these kind of situations where it's the x that's going to be squared. Okay, so I've got x minus h squared equals 4 times p times y minus k. And I've already got like a good chunk of that information. I know what the vertex is. That's the h and the k in that case. All right, so here's h, here's k. I plug those numbers in, -1 and 4. And then I just need one last little thing, and that's the p-value. Now, the p-value that I have, that is how far away the vertex is from the focus. Okay, so I'm going to zoom in on like this part right over here. I'm going to draw it up a little bit larger. Okay, so here's my graph. And then 1, 2, 3, 4. Okay, so the vertex is like right here. Okay, and then the focus is below it. So I've got to find that distance. That distance is p. Okay, so the coordinate for the vertex is located at -1, 4. The location of the focus is at -1, 63/16. So how far away are they? Well, if you look closely, the only difference that these two coordinates have is that they're a little bit farther away in the y direction. So all you need to do to find p is find out how far away these two y values are. Okay, so how far away is 4 from 63/16? So to do that, all I'd have to do is just like subtract them. Okay, so just subtract them. That's it. All right, so if I subtract these two numbers, 4 is really like, and you can, do this on your calculator, 64/16. So it looks like it's 1/16. And that's going to be the p-value on this, 1/16. Okay. And then there's one last little thing that you've got to account for. Just one. Okay, I promise. So you got the p-value. It's 1/16. So, you can put that in there. 4 times 1/16. And then there's one last thing, and that's that since it's pointing downwards, that implies that, we need to have a negative on there somewhere. So it's not just going to be a 1/16. It's going to be a -1/16. And you can, then simplify all of this stuff using your simple little math, right? Like the 4 times the 1/16, that's a fourth. So this turns into a -1/4. And then subtracting a negative, that turns to a plus. So there's my parabola equation. Notice that one took a lot longer than the circle. It's because there's a lot more moving parts, right? Finding out which equation to use, that's like an important thing, which equation. And then from there, you need to figure out, if what the p-value is, if you've got the vertex already. So what is that p-value going to be? And then after that, is the p-value going to be positive or negative? We don't know unless you can figure out like what direction that it's opening. Okay. All right. So we're going to answer those same questions for the next problem. And hopefully by then you'll kind of be in a rhythm and you'll see what we need to do for this. All right. So we've got this, let's see, vertex. So -4, -4. So if I graph that out, it looks like it's over here, -4, then +4. There we go. So it's like, right there. There's my vertex. Now, where is the directrix in relation to it? The directrix is also going to tell you how the parabola opens. So let's see where this is going to be. It says y equals 13/4. So 13/4, what is that as like a decimal number? Let's see. That's like 3.25, I believe. Oh, I should probably use my calculator to back my claim up. Let's see, 13/4. Yeah, 3.25. Okay. So 3.25 is, if I go up 1, 2, 3.25, it's like right there-ish. And if it's y equals that, this is a horizontal line. So it's going to just pass right through that point and go straight through there. There we go. There's our directrix. So you know how I said that the focus is always inside of the parabola? The directrix is always like behind the parabola. Okay. So like the focus is going to be somewhere in here, right? And that means that our parabola is going to open up like that. Okay. So that's really nice because now I know, what this thing it looks like, and therefore I know which equation I'm going to use. It looks like it's going to be another one of those cases where it's an x squared kind of situation. Okay. So I write out my equation, x minus h squared. And do you think I should elaborate on that? Why do I know it's x squared? I know that it's x squared because, just like the previous one, because when I drew out the vertex and the focus, I figured out that the parabola is going to be going downwards, and then this one's going upwards. Well, up or down parabolas only happen when you have like an x squared. Left and right opening parabolas only happen when you have a y squared. So that's like why I knew to use like the x is squared equation rather than the y is squared equation. Okay, so x minus h squared is equal to 4 times p times parentheses y minus k. And we've already got some stuff to plug in there, right? We already know the vertices or the vertex for this one. So h is -4, and then k is +4. And then now we can find that p-value from this. So the p-value is, again, just going to be like, how far away those two points are. So again, my vertex was located at -4, 4. And, the line itself is, behind it. And the line is y equals 13/4. So that means that no matter what x value that I give it, the y value is always 13/4. So let's say that I go out here to -4 on the x direction. That means that this coordinate on the directrix is going to be located at -4, 13/4. So very similar to the problem that we just had. We, to find that length p, we just find out how far away the y values are. Since the x values are the same, how far away are the y values? So how far away is 4 from 13/4? Well, we'd subtract them. And 4 is the same thing as saying 16/4. So if I, subtract those two numbers away, it looks like I'd get 3/4. So that's the length of p. That's like the value that I'd plug in over there. So let me go ahead and write that in. 4 times 3/4. There we go. P is 3/4. And then since the parabola is facing upwards, that means that the p-value is going to be positive. So it looks like I don't need to add any extra signs on there or anything. And now I just use my simple math to simplify this stuff. So x plus 4, and then 4 times 3/4 is just 3. And looks like that's going to be my answer. Okay, so this is the parabola in standard form for number 13 and number 14. I think that's a good place to end the video. If you have questions, don't be afraid. Go out and ask your math teacher, or you can get some help from some pals, or you can come see me in the morning or after school. Your choice. Okay, either way, let's go on to the next video. I'll see you then. We'll go over numbers 17, 18, 19, and 20. Okay, bye-bye.